I'm James Miller. I work for Turnitin. I'm a senior DBA there. This talk is about upgrading Postgres and doing it in a way where you can squeeze a whole bunch of machine updates into a small window and keep your customers happy. The scope of the work we were trying to do, we were trying to go from Postgres 9.2 to 9.4. We had 7 database clusters with combined 37 servers. The largest cluster was 667 gigs of data. We had machines in 2 data centers, and we were running on 2 different versions of CentOS. And at the end of the day, we wanted to be down for 4 hours because that's what we tell our customers we will turn off the service for at any given time. And we wanted to end up with one operating system that all of our databases were running on, because maintaining 2 operating systems is a pain in the butt and causes, unknown random problems that it's just better if you can unify everything. We actually decided that was too many machines to try to do in one day with 2 people for the most part working on it. And so we actually decided to take 2 4-hour windows and do the 4 main clusters first, and then move on to the other 2 clusters in the other maintenance window. We had another cluster that was a production. It managed our backups, so we could do that whenever, and we would interrupt our own backups, but it wouldn't be impacting the customers at all. So then it was a matter of figuring out how to actually do the work. The normal way that you go through an upgrade is just dump it, restore it, build out a new cluster of slaves. The problem is that actually just dumping our cluster ate most of our window, so there's no way that we could have dumped and reloaded, and it would have just taken us all day, and we would have been outside of our SLAs, and so that really wasn't an option. So a lot of people, when faced with similar situations, say, okay, just put in a Sloaney replicant so you can do logical replication to the new version of Postgres, and your life is good. But the problem is Sloaney is complicated, and we didn't have anyone who knew how to use it. And the idea of adding all of these triggers and everything and essentially doing an entire Sloaney deploy for an upgrade, it's like we had actually just gotten Sloaney out of our cluster the year before and replaced it with streaming replication. And so the idea of doing a lot of work to put it back in temporarily was not, we didn't look on that favorably. And it was just a lot of work to set it up and a lot of work to take it back out. And we would need the extra servers kicking around to replicate to. And database servers are expensive, and having a whole extra cluster was not necessarily something we wanted to do either. So we kicked around the idea of just running PG Upgrade, which is a nice tool. It's well documented. A lot of people have used it successfully. The problem we run into here is that then after the upgrade, you're still stuck rebuilding all the slaves. And we also had heard that there was a hard links option, and we wanted to invest, and that was a lot faster, but we didn't really know anything about what it was actually doing. So we had to do some investigation as to how to actually best use PG Upgrade. So, in the end, hard links are nice because during the upgrade, a lot of the files don't actually change. So rather than copying the entire database over from the old directory to the new directory, all of the files that don't actually change, you can just hard link. It's the same file, so it's fast. And it takes a minute maybe to even upgrade massive databases. You have to reanalyze after that, but it's really speedy. But the rebuilding out all our slaves still takes 3 hours, and it didn't really leave. On a Saturday, we could get away with just one slave. So we kicked around this idea, but it really didn't leave any room for errors on the upgrade or unknown circumstances or just getting a slow start, because most of the window would be consumed just to get the first slave up. And so that made us uncomfortable. We probably could have lived with it, but we weren't feeling good about it. So we heard rumor that rather than rebuilding all your slaves, you could actually rsync from your master over to your slaves, and it would actually be really speedy because all the slaves already are sitting on the data anyway. So there's just a handful of changes that happen as a result of the PG upgrade process, and if you just copy over the things that changed, you actually don't need to wait the full 3 hours to do a full rebuild of your machine. But we heard about this from word of mouth. It was someone mentioned like, oh, you might want to try this. I believe it was Josh. Yes, Josh had heard it existed and told us to talk to Bruce. And while we were talking to Bruce, Stephen Frost overheard us and was like, oh, I've totally done that. And he actually wrote some documentation as well, which. But it was, on the development wiki. It wasn't like in the main Postgres docs. And we heard some people, like Stephen, said, yeah, we did this, totally worked. I would recommend it. We also talked to other people who said, I tried that and it didn't go so well, and at some point we gave up and did Sloaney or something else. But the carrot at the end, the carrot was a big one. It's getting the upgrade done in minutes rather than hours. And so it made it a worthwhile thing to look into more closely. So ahead of the process, we tested a lot because we're playing with all of our production databases, and it's scary. And in our planning and testing, we actually screwed up a lot too, and we learned that don't skip steps, just write them all down so you know exactly what you're doing, because you're doing a lot of steps on a lot of different machines, and if you don't do them in the right order or forget a step, it's very easy to hose your whole cluster. And if it's your production database cluster and you stuck restoring from backup, and that's not anything that we wanted to do. So we were very verbose. In the end, we, even simple steps, we write them down just to make sure that we could, check them off the list to keep ourselves from shooting ourselves in the foot the day of the maintenance. Because in testing, we had, early on we had more failures than successes. So we had enough failures that it made us very cautious. In the end, we spent about a month and a half practicing. Totally overhauled our configuration management, tested lots, broke things lots, fixed our processes, reset clusters. That was always fun, because when you hose your cluster, you get to build it all out again. And we were dealing with full-size data sets because timing was critical. We wanted to have full-size databases to test with, so we'd actually get a good idea of how long the upgrade was going to take on the day of the process. But the problem is that when you hose your cluster, you're stuck building out, many gigs of database, and it's just slow. We found that actually the PG upgrades piece was really easy. It was never a problem. Like, we get to that step, it worked just like the documentation said it would. Had great success with that. This is actually the developer documentation that we were working with. And on this, at this website, there's step 10, which actually is the piece that deals with rsyncing to the slaves. So here's what was in the documentation originally. It's pretty easy. The idea is that you tell rsync to look at hard links, and that way it will notice that when you run the PG upgrade, you have the old data directory and the new data directory, and the idea is that when you do your rsync, it goes through and sees that you have a bunch of hard links, and it just creates them in the new location rather than copying them over again. You do have to add this size only flag, otherwise your checksumming ends up taking a really long time and you don't get the minutes of result that you were expecting. It's if you do size only, then you're not. The problem with that is that you are only looking at the size, and the files can be actually different, and if they're the same size, they won't get rsynced. So our actual first big hurdle was just using rsync. None of us were really good with it, even though it's a common tool, and it seems like something that everyone would use occasionally. None of us really had, and it's not necessarily it's like when you're learning how to drive, you don't necessarily want the nicest, fastest car. So we actually had issues getting, we have like our xlog directory symlinked into our data directory and just making that work properly. And then when you rsync over, you have the master's configuration, so you have to reset the configurations back to make it so it wants to be a slave and not be a master. And in our case, we actually had some issues with our configuration management not wanting to assign ownership at the same time it created files, and so we managed to hose our clusters a handful of times because we tried to start up the slave and had configurations that were only readable by root, and then bad things happened. And then we got to go through the slow and tedious process of resetting our cluster, which we probably did 50 times. But that's why you test. And I would recommend anytime you're doing major changes, you should probably allocate many times more time for testing than for actually doing, because things go wrong. And it's good to know if you do it enough times. If you only do it once and you're successful, you might get overconfident that, oh yeah, this is no problem. It's like there's a lot of failure modes. It's nice to do it enough times that it's like if you haven't failed at least once, you probably haven't tested enough. Maybe not always, but we also ran into some other hurdles. The rsync step, when we were initially trying things out, didn't actually go fast as advertised, even though we were looking at it. We looked at the documentation. As far as we could tell, we were doing everything the way we were told to be doing it. And after playing with it a lot, I realized that when the documentation is talking about the rsync, it's kind of using the default Postgres directory, so everything's varlib, PGSQL, and then the version number. And we actually didn't do that for company policy reasons. We like to have all our non-standard mount points mounted under the serve directory because it makes monitoring and things easier. So we had our database installed at serve PG data. We were installing the new version at 9.4 data, and when we were actually rsyncing this direction, rsync would go through, and rather than noticing that things were hard linked, it would actually copy the files, and then later on, it would try to do the hard link, and it would go, oh, okay, this is the same thing as that, and would hard link rather than doing the checking for the hard link first and then copying it. And so in the end, we found that just moving our data here to 9.2 data, and so it actually sorted before 9.4 here, magically solved all our problems. But it took us a long time to figure that out. And it was very frustrating, especially since none of us were comfortable with rsync anyway. When we were trying to do what the doc said to do and it wasn't working, it was a little bit maddening, and we, it's like, what are we doing wrong? But if you're using the default directories, that's not going to be a problem. But if you have things mounted in weird places, just be aware that rsync might not be able to find your hard links if you don't reorganize where things are first. Namely, you need the one that has the existing files to happen first, and then the new target to happen after. The second hurdle we had was actually our configuration management. The way it had been previously set up, there was we were using CF Engine, but we had a CF Engine rule for our development environment and a CF Engine rule for our staging environment. And we have a bunch of different environments, and they all had entirely different configurations from each other. And so after overhauling the development environment to be able to get it to 9.4, like doing it on the next environment was actually just as much work because it was an entirely different configuration. Things were not actually quite set up the same. And so in the end, after doing a couple of environments, it was like, this is ridiculous. If I'm redoing the configuration, I'm just going to redo it all the way. And so I actually overhauled it all. So all of our development, or all of our environments use the exact same rules. And so I only had to, I had to come up with the new configuration once and didn't have to worry about it anymore. And it also made things standard between the environments, because one of the issues we were having is because everything was managed separately, not everything was 100% the same between all the environments, and that caused its own headaches. But in the process of learning all this, there's that pain of resetting, which every time we had to do it, it ate hours. So a lot of it was test, and then, oh, we screwed it up, we'll try again, fire off the builds, and then try again the next day. So, never, sometimes it's good to use things as an excuse to fix your technical debt. You got to do it sometime anyway. Preferably, you don't want your technical debt biting you on the day of the maintenance. The other thing we discovered is don't init the slave. The thing I mentioned earlier about rsync, if you do a size-only copy, it will not know that two different files that are the same size are different. When you init the slave, it creates some IDs in a fixed size file, and when you do the rsync, it leaves the old one, or it leaves the initdb one there, and you don't get the one from the master, and nothing works. And so, yeah, you have to have a nice clean directory on the slave. Otherwise, you end up with a broken cluster. So the next problem we had is once we got things to a point where, for the most part, we could get things copied over, rsynced, things happened fast, everything looked okay, Postgres would start, but then we would try to connect to it, and it would be in it's like in recovery mode, or, it just like we couldn't get into the, everything looked like it worked until we actually tried to use it, and then it would just be in a weird recovery mode that was not helpful. And so the way we actually solved that was by, before doing the rsync, we did PG start backup. And once we started doing that, it fairly consistently worked, after that. So the development docs that I pointed at earlier say that you don't need PG start backup, but I would do it anyway, because our life got better when we started doing it. So the next hurdle we discovered is that one of the machines, ahead of the maintenance window, we were trying to pick off the older CentOS boxes and get them replaced. But about a week before the maintenance, we noticed that one of the CentOS boxes that we wanted to retire was actually the master database. And one of the reasons we were going to 9.4 is you couldn't change your masters without rebuilding out your slave cluster. So we were like, oh, we want to retire this machine, but it's the master, and that's unfortunate. So we actually went with do the upgrade to 9.4, and then once you're on 9.4, then you can actually point your slaves over to the new box, and that's okay. And so that is the approach we took. It's like, we're going to 9.4, we'll just pretend that nothing is wrong. And when we got to the day of the window, for the most part, things worked reasonably well. 2 clusters went off without a hitch, went off as planned. One of them took significantly longer, 3 hours. It's ate a lot of our maintenance window, but we had enough. That was just one machine in the cluster, and so we actually had enough machines up by the end of the maintenance window that we were able to go back live. We did have one cluster that was special, and it was an environment that was kind of production but kind of not, and didn't get love for a long time, and it ended up going badly. And so we'll just pretend that one didn't exist, because it wasn't actually the upgrade process there, it was more technical debt. So another issue we had is there was hardware failure on the day of the maintenance. We actually had 2 hard drives in a RAID blow up. And the real solution was, plan for the worst and don't panic when you actually get some of it. It actually went down pretty smoothly, even though we had multiple failures, because we tried to build in a little bit of padding and practiced a lot. Even though we had multiple things go wrong on the day of the maintenance, everyone kind of kept their heads screwed on, and we were able to get through the process and get out at the end of the maintenance window pretty much okay. But I would say a big component of not panicking is lots of preparation. The second window actually went off without a hitch. It was pretty much, we all got up early on Saturday and were done working early. So the one big mystery we have is why that one slave went slowly. We did the same thing to it that we did to everything else, but for whatever reason, the rsync on that one still crept along at slightly faster than a full rebuild would have been, but still pretty slow. We're not sure why. One theory is hit bits. I've heard another theory floated around that the way the same sorting issue that caused the rsync problems to begin with might have sorted, like you don't necessarily, like if you type ls in a directory, you don't necessarily get alphabetical sorting. Like sometimes there's no guarantee which order things come back in, and for whatever reason, it could have come back in the other order and gone slow. But at this point, we don't know. It's like, that was, of all of the machines we did, only one of them crept along, but it's something to keep an eye out for as well. Yeah. We've had various theories, and it's going to have to be a mystery because we destroyed the data with the rsync. It's like it's hard to replicate. But the one thing we did notice about the slave that went slow was, unlike all the other ones which had just been freshly built on the new CentOS, the one that went slow was actually the first newer CentOS that we deployed, and it had been running for several months, whereas all the other ones had just been upgraded from 5 to 6, and so those builds were actually pretty fresh. And so we are somewhat suspect that there might have just been drift between the slave and the master as a result of it being up a long time. So as a precautionary thing, it probably wouldn't hurt to rebuild all your slaves just to reduce the chances of that problem biting you, assuming that it was actually caused by the being up a long time. Could be a red herring, but it's file it under the it doesn't hurt to be extra cautious. So in summary, the most difficult piece of the upgrade wasn't the actual upgrade, which was easy. It was making all the moving parts work together. Establish a process ahead of time, because that makes it a lot easier to remember all the steps you're doing, all the places. Test a lot, and that's really the, I would say one of the most important things, because it's easy to screw up. And if possible, rebuild your slaves, and so they haven't been sitting around for a long time at the point you do the upgrade. So thanks. And I also wanted to mention that some of the things from this talk actually made it into the documentation I referenced here. So, thanks to all the people who helped us through this process, and thanks to the people who are good at actually going through and documenting things, because I am not, and I've been meaning to go alter this documentation for a while and never, or submit ideas for how this could be altered, but when I looked at it yesterday, actually some of the things from this talk had already made it into the documentation. So thanks to all the people who write things down for everyone else. Are there any questions that people have?
Is there a way to run or do updates while the system is still running? Is there such way?
Not that I know of. You could do, there's the Sloanie. Then you still have to have a little bit of downtime while you're cutting over to the new cluster, but I think Sloanie is the closest you'd get to that. Yeah, I don't. Yeah, we really can't get by with just the master. We tip. Yeah?
What would you have done differently if you were in a hosted environment? It sounds like you had your own hardware.
I would expect a hosted environment to be largely the same if you're like on a, well, by hosted environment you mean like EC2, or do you mean if someone else is actually managing your cluster for you?
Well, someone else's servers, so not the cloud.
Okay.
EC2 or
I'm probably not the best person to ask that to, because for the most part, I'm playing with metal, because we have servers that are currently big enough that it would be cost prohibitive to put them on the cloud, and so as a result, I don't have a lot of cloud experience. But I don't imagine that it would affect the process a whole lot if you're actually managing the database, because it's still all just rsync. You know, if you can rsync between the two nodes, I would imagine it behave just like if you were owning the hardware yourself.
Right. And then the other question was, it was a contractual agreement that you could only have a 4-hour downtime?
Yeah, that's our SLA was. Yeah, we have. I'm not sure exactly what the verbiage was. I think we can squeeze out another hour if we need to, but yeah, it's we try to keep our maintenance windows to 4 hours if possible. And I know that at some point I think we could have potentially, we might have more time, but we like to have it 4 hours. That way, if things go wrong, we're not in breach of contract. So I think we try to restrict it for that reason. But yeah, we have SLAs that we had to meet. All right. Thanks a lot. Oh.